And this will be my last example for improper integrals. Again, it doesn't look like improper integral, it looks like a regular integral. Why am I calling this an improper integral?
Because if we plug in 0, then it's going to be undefined. Wait, no, it wouldn't be undefined. A round under 0, right?
When would this be undefined?
To both.
When
2 and 0.
the denominator is
No,
0.
when you plug in 0, it's fine. 4 minus 0 is square root of 4, that's 2. That's not 0.
It's technically.
But what about the numerator?
When you plug in 2.
Numerator being 0 is not a problem. It's really the 0 in the... Huh?
It would be 0 over 2 if you plugged in 0.
Yeah, but what was I saying? It doesn't matter for the numerator. You want to see when the function is undefined, so it goes to like infinity. That
So
only
if-
happens when the denominator is
So if
0.
we plug in 2 for x, it gets squared. 4 minus 4, radical that, it's 0.
That's when it becomes a problem. When 2 goes in here, that's a problem. Okay? When 0 goes in here, that's not a problem. In fact, none of the numbers are a problem except the value of 2. Okay? So that's an improper integral because of the 2. And you have to know that because you have to replace that end by a letter. Okay? So we really have to interpret this as limit of a going to 2 from negative side, and you integrate from 0 to a, x over square root of 4 minus x squared dx. Okay, now let's try to do u substitution. This time I will actually change the bounds as well, okay? So what should I take u as?
Square. Well,
Square
you
root.
take it as square root of 4 minus x
Yeah,
squared.
the entire
square
thing,
root.
right? And then you square both sides. You should slow down a little bit, okay? 2u to u. If you differentiate 4, you get 0. If you differentiate this, it's negative 2x dx. And then you want to solve for dx by dividing by negative 2x. So that you get dx equals to negative u over x du. Okay, I also said I want to change the bounds as well. So when x is a, that makes u equals to
Square root of 4 minus a squared.
4 minus a squared, square root. Okay, good. When x is 0, u becomes,
2.
yeah, that's square root of 4 minus 0, which is 2. Therefore, now this integral would still be limit a going to 2 minus, but the integral would be 2, the square root of 4 minus a squared of x over u times negative u over x du. Because dx is now replaced by this one, right? And you can see that u and u cancels, x and x cancels, and you can also use this minus to switch these two around. Okay? So I'm going to put this limit of a going to 2 minus integral from square root of 4 minus a squared to 2 of 1 du. Now, why did I want to switch these around? Well, you don't have to. You can just do the calculation without doing so. But in my mind, when a is anything bigger than 0, square root of 4 minus something would be less than square root of 4. 2 is square root of 4, right? So this is less than this. In such a case, I like to change places because I want small to large. Okay? That's why I did it. But actually, you don't have to do it, and the answer will come out the same. Okay. Now you integrate 1. What do you get if you integrate 1?
U.
Right.
Dr. Owen,
Yes.
wouldn't it be negative 1? Because there's a negative sign right there.
So I just explained that this negative was used to switch these two around.
Okay.
Okay, and then you get integral of 1 will be u, and you plug in 2, and square root of 4 minus a squared will be plugged into this one, and you subtract, so it's going to be limit of a going to 2 minus of 2 minus square root of 4 minus a squared. And then there's nothing stopping me from plugging this in, right? This time there's no like L'Hopital's or anything to do. It's just you plug it in and that's the value. Right? So you're not, okay, so when 2 minus plugs into a, what happens? 2 minus square root of 4 minus 2 squared, which is 4, right? And therefore you get 2 minus 0, which is 2. Okay. Right. So this is a case where you have a definite number. These improper integrals sometimes will give you infinity, sometimes it's going to give you a number. When it does give you a number, you should also check whether it makes sense. Because, for example, this is a positive valued function from 0 to 2, right? The denominator is always positive, and x itself is positive from 0 to 2. So, therefore, the answer should be a positive number. If you get a 0, that doesn't make sense because you get something positive over a positive domain, so how can that be 0? Something's not right. Okay? So that kind of thinking can help you to avoid making a mistake, just like what I just did. I put a 0 there, but then, hey, that doesn't make sense, so change it. Okay. That's very important for taking exams.